Okay, so that same knowledge we work with all absolute values. If we are talking of the absolute value of less than negative 3 minus 4 plus 5. So what is inside there is going to give us negative 3 minus 4, that would be negative 7, and then we've got a plus 5. So negative 7 plus 5 will give us a negative 2, and that will give us a positive 2 at the end. So that is how we deal with absolute value functions. So now, with the same knowledge, we want to advance our knowledge on absolute value functions. And this portion is very important. You barely find a past paper where questions lack on absolute value equations and such a thing. So now, if you've been given the absolute value of x, what do you think this is going to give us? Who can help us? No one. So now, the absolute value of a number should always be positive. Okay? It should always be positive. So the absolute value of x is x. Same, the absolute value of negative x should give us x. Now, if we have the absolute value of x like that, this can also be written as, so we are saying that our x can either be negative or positive, but at the end of it, or when a number is coming from absolute bars, it should always be positive. So now, who can help us? This is already negative. What should we do to this one for us to make it positive? What should we do? No one knows. Are we together? Are you able to get me, you people? Okay. Alright. So now what we are saying is, if we have got the absolute value of x, it can either be negative x or x. Now that depends with what numbers we are talking about. So for this one to work, unless we are talking of negative numbers, because the absolute value of x should always be positive. So we need to multiply that with a negative. So this is valid only when x is negative. In other words, when x is less than 0, that is when it is valid. So for all numbers which are less than 0, and which numbers are less than 0, those are negative numbers. So whenever we get a negative number, we put where there is x, such as a negative 4. This negative will multiply with this negative. At the end of it, or it is going to be positive. So that is for which it is valid. Now for this one which is positive, it is only valid when x is greater than 0. It can be greater than or equal to 0. Okay. So that is what we are talking about. Is this point okay? So now it is from this knowledge that we are able to plot our graph. If we've got x here and then we've got y here, please, you need to get this point, otherwise if you miss it, you've missed it. So now we are dealing, if you are talking of the absolute value of x, we are dealing with two equations. It can either be this equation or this equation. Imagine our function was y is equal to the absolute value of x. So that means our y can either be negative x for values of x which are less than 0, or positive x for values of x which are greater than 0. So this is how it will be varied. So now if you are talking of only this portion here, what we are saying is y is equal to x. Now which line gives us y is equal to x? So what we are saying is, if this is 1, this is going to be 1. If this is 2, this is also going to be 2. So we are going to start from here going up. So that is for which is going to be varied. Remember, we are starting when x is greater than 0 and our 0 is at this point. So we are going straight in that way, like that. Now, whenever we are talking of a negative x, if you refer to a negative x, it is only valid, so y is equal to negative x is only valid when our x is less than 0. That is when our x is negative, so that would be only valid. So what we are saying, if y is equal to negative x, that means if our x is negative 1, then our y will be positive 1. If our x is negative 2, then our y will be positive 2. So what our equation is going to become is it is going to go in the opposite direction in that way. So this is called redefining the function. So that is a method of redefining a function. Are we fine with that one? So that is the most basic example that I can give. So before I go to anything a little bit complex, is that okay? All right. So in case they've told us to sketch, they give us f of x is equal to, let's say the absolute value, let's put a negative in front, the absolute value of x plus 1. How do we sketch this graph? Now, we want to redefine our function. So this also means that our function f of x is equal to, okay. So remember we've got a negative which is there. Now we know that we are interested with what is inside the brackets there, right? So that is our interest. So if we get what is inside the bracket, we equate it to 0. So the first thing is we need to equate what is in the inside. Those of course are not even brackets. What is inside the absolute values, we equate it to 0. So if we equate our x plus 1 to 0, what we are going to find is x is equal to negative 1. So this is a point where our graph is going to be changing signs. Okay. So what we are going to have is this. We are going to have a number line where this is our negative 1. Now we want to find the behavior of this portion when x is this region or when x is in this region. So now we need to get any number that is from negative 1 going in this direction. So any number which is smaller than negative 1, such as a negative 2. Let's put a negative 2 there. So negative 2 plus 1 is going to give us a negative 1. So in this region, our values of x are going to be negative. Okay. And then if we get something here, such as a 0, because a 0 is greater than a negative 1, we put there. What we are going to have is 0 plus 1, which is a positive 1. So in this region, our values of x will be positive. Okay. So now what we are saying is, if we get our actual function which we have, we remove the absolute values. Remember, don't forget about this negative. So that negative is just part of the equation. Okay. We get what is inside. The only way that this is going to be positive is when our x is bigger than negative 1. So we have gotten the positive version of what we have. Don't worry about this negative, it's part of the equation. That's why I'm not talking about it. So we are only going to get this to be positive when our x is what? Greater than negative 1. So these numbers which are this side are greater than negative 1. But whenever we get something which is less than negative 1, our function is going to be negative. But remember what comes out in the absolute values, we always want it to be positive. So in that case, to cancel the negative which we are finding, we need to multiply the function by another negative. So forget about this negative which is already part of the function. So we have got negative. So the function, what we are multiplying, this thing which is inside the brackets, I mean inside the absolute value symbols, we are going to multiply it by a negative. For values of x which are less than or equal to -1. Why are we multiplying it by a negative? Because we are going to be finding a negative value. So to make sure that what comes out from the absolute values is positive, we multiply by this negative, but make sure don't tamper with this negative because it's part of the equation. That's why I've still written it there. Are we fine with that one? Are we together? Okay, it seems we are together because people are not responding. So this is further going to give us, we can distribute this negative which we have. So that will be -x minus 1. And then distributing, we can multiply this negative and that negative, it will give us a positive. So what we are going to have is x plus 1. So this is for x is greater than -1. And then this is for x is less than or equal to -1. So now at this point, we can now draw our function. So our function, we've redefined this function. It has given us this. So we have got two regions. It can either be positive or negative. So what we have is our x and our y. So our turning point is at -1. So we have got -1 there. So whenever we are talking of numbers which are greater than -1, remember greater than is starting from here going this side. The equation that we are going to use is this one. Whenever we are talking of numbers less than -1, we are going to use this equation which is here. So now getting this equation which we have, we can simply get any values. So what we are saying is f of x is equal to, we get this one, -x minus 1. We've got x and y. So let's say if our x is 0, what will be our y? So we put 0 here. So that will be -0 minus 1. Now -0 is simply 0. 0 minus 1, it will be a -1. If let's say our x is +1, remember we are talking of values of x. For this equation that we are using here, we are only talking of values of x which are greater than -1. So from -1, we are going this way. So we first used 0. Let's try to use a 1. Okay. So if we use a 1, please, for here we're not going to use a -1 or a -2. That is because it is outside our range of values which we want to use. So if we use a 1, we put it there. It will be -1 minus 1. It will give us a -2. So we can simply plot those 2 points. We have got 0, -1. Let's say -1 is here. So that is the point. And then you've got 1, -2. This will be our point. And remember, we are starting from there. So our equation is starting from here, passing like that. So that is for the first portion, which is this one. And then we've got the second portion, which is here. So whenever our x is less than -1, the function we are going to use, f of x, is going to be x plus 1. So for anything less than -1, so for this one also we can make a table of values where I've got x and y. Let's say if our x is, now we are taking values of x less than, going this way. So let's say if our x is -2, what will be our y? That will be -2 plus 1, which will be -1. What if it is -3? -3 plus 1, which will be a -2. So our x is -2, then it will be -1 for y. For x is -3, then it will be -2. So we have got those points. So our graph is going to pass somewhere. Starting from there, it will pass somewhere like that. So that will be the sketch of the graph. redefining the function. Are we fine with that one? Or there are questions? Okay, it seems it is fine. Let me try to do another example. Or maybe people who just want to, those are here asking are not here. Okay, let's say we've got f of x is equal to the absolute value of 2x minus 1. So we want to sketch this function by redefining. So the first thing we are going to redefine this function. Now, we first need to equate what is inside there to 0. We find the point where the graph is going to change. So that will be 2x plus, 2x minus 1. That should be equal to 0. So that is 2x is equal to 1 and our x is equal to 1 over 2. So we now make a number line where this is our 1 over 2. So if we get any value this side, so any number which is less than 1 over 2, what number can we give? Such as a 0. If we put in this function 2x minus 1, remember we've just gotten what is inside there. Okay. If we put here a 0, that will be 2 times 0, it will be 0. 0 minus 1 is negative. If we get something above a half, such as a 1, we put a 1 here. 2 times 1 is a 2. 2 minus 1 is a 1, which is positive. So we've got those two regions. Now let's redefine the function. So this, it can also be written as f of x is equal to, so we can have the positive version, which is the 2x minus 1, just the way it is as positive. So this is positive when x is greater than half. So that is when x is greater than half. And then it is negative when x is less than half, but we don't want anything negative. So to make sure that it maintains the positivity, because whatsoever should come out of the absolute value should be always positive. So we multiply our function with a negative. So that will be times a negative. And this is value for x is less than 1 over 2. Now we always want this function to be continuous. So if this is less than, this should be less than or equal to. Or if this is less than, this should be greater than or equal to. So we can put an equal to any of these two. So what we just want to make sure that our graph joins. Otherwise, if this one will be less than, this is greater than, at one point they will not meet. For example, our graph might be like, it was going, when it reaches this point, it doesn't touch half, and then it continues. But we want it to touch that point. So that's why we are putting an equal to one of those. Okay, can put even to that one. So now from here we can go on simplifying the equation. What you have is 2x minus 1 for x is greater than or equal to 1 over 2, and we can distribute the negative. That will be negative 2x plus 1 for x is less than 1 over 2. So at this point I can remove that, and then I can write this side so that I have space. 2x minus 1 for x is greater than or equal to 1 over 2, and then negative 2x plus 1 for x is less than or, for x is less than 1 over 2. Now from here we can now try to sketch our graphs. Okay, so that is what we have. Remember, our point of interest is 1 over 2. So 1 over 2 can be somewhere there. So now, what we want, when we are talking of numbers which are greater than 1 over 2, starting from here going this side, we are going to use the first equation. So that is, okay, f of x is equal to 2x minus 1 for numbers which are greater than. So we can just try to see some values. So if our x, we want numbers greater than half, 1 is greater than half. If we put in there, we are going to find 2 times 1 minus 1, which will give us a 1. So it will be 1 comma 1. And then if it is 2, because 2 is also greater than half, 2 times 2 will be 4. 4 minus 1, it will be a 3. Okay. So what we have is 1 and 2. And then we are going to have a 1, a 2, and a 3. So the first point is 1 comma 1, which is here, and then 2 comma 3, which is here. And then we can draw this graph starting from the point 1 over 2. I mean 1 comma, yeah, 1 over 2. We continue like that. And then when we are talking of values of x which are less than, we are going to use that equation. So that is f of x is going to be negative 2x plus 1. So we're going to get values of x, and y. So if our x, let's say we want something less, 0 is less than half. If we put there, we are going to find that our y will be 1. If we put a negative 1, negative 2 times negative 1 will be a positive 2. Positive 2 plus 1, it will be a positive 3. So I've got 0 comma 1 and also negative 1 comma 3, which is somewhere there. And then we join those 2 points. Though the kind of sketch, okay, it will be somewhere there. So it means our 1 should be somewhere here, and this point is somewhere there. Okay, since I'm sketching. So that will be our graph which is going to come out. Is that fine? Are we okay with that one? All right. So we can look at another example which involves 2 absolute values in the same, and then we want to sketch by redefining. So if we have got f of x being equal to the absolute value of x minus 2 plus the absolute value of x, how do we sketch this one? Now for this one, we first need to find this point, where this point is equal to 0. So x minus 2 is equal to 0. That is x is equal to, okay. So it is 0 at x is equal to 2. And then this one which is here also, I need to equate it to 0. So x is equal to 0. So these are the 2 points which we have. And then we need to find the sign for those 2 points. So we have got x being equal to 0 and x being equal to 2. Now we get the equations, the 2 equations which are inside the absolute values. So the first equation which we have is that one. We just get what is inside. We have got x minus 2. And then for this one, it is simply x. Now I want to find the behavior of these 2 functions when x is less than 0 or between 0 and 2 or greater than 2. So what we are going to do is, if we get something which is less than 0, such as a negative 1, we put in this one, what will be the sign? So that will be negative 1 minus 2. It will be a negative. What of in here, if we get a negative 1? Negative 1 we put there. It will be a negative 1, which is negative. Okay. And then if we get a number between 0 and 2, between 0 and 2, such as a 1, we put here. That will be 1 minus 2. It will still be a negative for this one. But if we get a 1, we put in this one. 1 is positive, so that will be positive. If we get a number that is above 2, such as a 3, we put here. 3 minus 2, that will be a 1, which is positive. And then we get a 3, we put there. That is still a positive. Okay. So now, having found these values, we now redefine our function. So that will be our f of x is going to be equal to So in this region, both of them are negative. Now to maintain the positive, we need to multiply our two functions with a negative. So this one, because it has given us, we can see that this one has given us a negative, which is here. But we want to maintain the positive. Okay, we want to maintain the positive. So we're going to multiply that function with a negative. So we're just writing the way it is here. But we are going to multiply it by a negative, so that this negative will not be the result. Remember, when something is coming from the absolute base, it should always be positive and not negative. So if it is negative, multiplied by a negative. Okay. And then this one also is negative here. So instead of writing only positive x, we are going to write negative x. Okay. That is for values of x which are less than 0. So we are getting values of x from 0 going in this way. Now what are values of x which are between 0 and 1 and 2? Now as you can see, between 0 and 2, this one is negative. So to maintain the positive, we need to multiply that one by a negative. But this one is still positive, so we don't need to multiply it by anything. We just need to get it the way it is, like that. The positive x. That is for values of x which are between 0 and 2. So we are going to say 0 is less than or equal to x, which is less than 2. Here, because we use just less than 0, so we are going to use less than or equal to 0, so that the 0 won't be a point of discontinuity. So you can even put that on that one. It doesn't affect, it doesn't matter, in other words. That is only to show that this graph continues. Now if we come to this region, numbers above 2, both of them are positive, so we are just going to get the way it is. We'll just remove the absolute values. So that will be x minus 2 and then plus x. This is for values of x which are greater than or equal to positive 2. Same here. This one I just used less than. Here I've used greater than or equal to. And that shouldn't confuse us, because our only aim is to make sure that our 2 doesn't become a point of discontinuity. That is why we are putting equal to. We can even put a equal to there. Okay. Now from this point we can simplify what we have. So that is going to give us, we can distribute this negative. That will be negative x plus 2 and then minus x. And then we can distribute also this negative. That will be negative x plus 2 plus x. And then this one is just the way it is, x minus 2 plus x. So we can go over simplifying. We can see we've got a 2, which we can write. And then we've got negative x and negative x. That will give us negative 2x. And then if we come here, this is positive, this is negative, it will cancel. So that will give us a 2. And then if we come to the down part, we can see a 2, an x, and an x. So x plus x, that will be 2x. And then we've got a negative 2, which is there. So we need to note our regions we are talking about. So these are the regions which we have. We shouldn't forget that. So let me just... Okay. Let me just simply put what I just wrote there at this point, f of x. So the very last thing which I wrote, the simplified form, what I wrote was 2 minus 2x. That was for values of x which are less than 0. And then 2 for values of x between 0 and a 2. And then 2x minus 2 for values of x which are greater than or equal to 2. Now for this, we need to start now drawing the graphs. We've got x and we've got y. Now if we start with this one, we are talking of values of x which are greater than 0. So we are starting at 0 there. Okay. So greater than 0, we are going in this direction. What will be the behavior of the graph? So for values of x which are greater than 0, we are using the equation 2 minus 2x. 2 minus 2x. So we're going to get x and y. So let's get a value of x which is greater than 0, such as a 1 we put there. If we use a 1, 2 minus 2 minus 2 times x. So that will be 2 times 1, which will be a 2. Then 2 minus 2. So if this our x is 1, then our y is going to be 0. Okay. We can also get another value of x which is greater than 0, such as a 1. Okay, I think we can only use a 1 at this point, because immediately we go to a 2. If we reach to a 2, then we've gotten into another region, which is not the region which we want. Okay, so we can just simply use this 1 point. So if our x is 1, our y is going to be, what did we even find here? Let me just rewrite that. So we are talking of y is equal to 2 minus 2x. Okay, so that is what we are writing. Now we are saying for values of x which are, I think I even got the wrong region, and it seems people are not speaking. We are talking of less than. Can I ask what numbers are less than 0? Hello, what numbers are less than 0? Okay, it's negative numbers. So for that one, I use the positive number. So I want negative numbers. So let's use negative 1 and negative 2. So if we put negative 1 here, that will be negative 2 times negative 1 to be positive 2. Positive 2 plus 2, it will give us a 4. If we use negative 2 there, negative 2 by negative 2 will give us a positive 4. Positive 4 plus 2, it will give us a 6. So when we start for values of x which are less than 0, if we start from 0, if we have got negative 1 and negative 2, we are finding, let's say this is our 1, 2, 3, 4. Okay, let me just use 4. So I got negative 1 comma 4. This is 1, 2, 3, 4. Okay, that is what we have. So remember, we are starting from 0. That is our starting point. Values of x less than 0. That's our starting point. So we will start from 0 and join with the point which we have. Starting from 0 and joining with the point which we have, like that. So that is our graph for the first one which we have. Now we need to see again here the minimum which we are supposed to have. It's not even supposed to start from here. The minimum which we are supposed to have. Let me just clean this portion. Okay. I just want to write it properly. I'm not changing anything. That is for x is less than 0. Now we want to look at the minimum point that we are supposed to have. Okay. Remember, we are talking of the point 0. When our x is greater than 0, and we only want numbers which are, x is less than 0, and these are the numbers which we have. We are finding first this point as our negative 1 comma 2. Now let's first use when our x is 0, the 0 itself, the 0 which we have here. Let's say if our x is 0, what will be the behavior? What will be the value for y if we input there? So please, it will be very important if we start with the very number which we have there. What will be the value for y if our x is 0? Who can help? If we put a 0 here, what will be y? It will be 2. So if our x is 0, y is going to be 2. So we are starting from this point and then going to the negatives. So it is from this point and then going like that. So it is not starting from the point 0, 0. Okay. Now if we go to the values of x which are between 0 and 2, as long as we are between 0 and 2, what we are finding is that the value for y, f of x, is going to be 2, as long as x values are from 0 to 2. Okay. So as long as we are from 0 up to 2, the graph will always give us a 2. That is the function which we have. So as long as our x is starting from 0 and then 0, 1, 2, the graph is always going to be 2. But if we go beyond those points which we have, if we go beyond 2, that is when x is greater than 2, we are going to use another equation, y is equal to 2x minus 2. So now we need to find some values, x and y. So for values which are greater than 2, such as, let's use a value such as a 3. If we put a 3 there, it will be 2 times 3, which will be 6. 6 minus 2, it will give us a 4. So I think this point is just enough. We can only use 1 point. So we have got a 3 there. So if we have got 3 as x, then our y is going to be 4. It will be somewhere there. So we can start from where the graph ended and then pass through that point. Pass through that point. So this is the graph for the function f of x is equal to the absolute value of x minus 2 plus the absolute value of x. So this is how it's going to look like. Are there questions before I look at the last example? Okay, let me look at the last example then. Maybe we are going to get it from there. So I want to sketch the graph. Y is equal to the absolute value of 2 minus x minus x plus 2. So remember, the first thing is you need to equate this to 0. So 2 minus x is equal to 0. You can take the x that side. That means 2 is equal to x. So that is the first point. And then equate this to 0. X plus 2 is equal to 0. That means our x is equal to negative 2. So we've got 2 points. We've got negative 2 and positive 2. So what we are going to get, you simply get what is inside the roots there. Just what is inside. I mean, what is inside the absolute bars. Okay, we start with the first one which we have. That is our 2 minus x. And then we're going to start with this one. And then write that one, I mean. Our x plus 2. Now I want to find their behavior in these 3 regions. This region, that region, and that region. What will be the behavior of these functions? So if we get a number less than negative 2, such as a negative 3, we put here. It will be 2 minus negative 3, which will give us a 5. And we know that a 5 is positive. The same negative 3 we've gotten, if we put it here, to be negative 3 plus 2, which will be a negative 1. So in this region it is negative. And then we can get a value between negative 2 and positive 2. The same place we can get is a 0. So if we put a 0 here, 2 minus 0 is a positive number. If we put a 0 here, 0 plus 2 is also a positive number. If we get something above 2, such as a 3, so if we put a 3 here, 2 minus a 3 will be a negative number. And then we put a 3 here, 3 plus 2 will be a positive number. So those are the signs which we have. Now let's redefine the function. So that will be y is equal to, as we can see, the first one, the 2 minus x, in this region is positive. So just get the way it is. 2 minus x. And then minus this portion, minus. Now this one is negative. Because it's negative, we are going to put another minus. And then we write it, x plus 2. Remember, don't tamper with this minus because it's part of the equation. Okay. This is for values of x which are less than negative 2. What of between? So between, you can see that both of them are positive. So we just get the way it is, just removing the absolute bars. So what we have is 2 minus x plus 2. That is for values of x between negative 2 and positive 2. And then for values of x which are greater than 2, you can see that this is negative. So we're going to put a negative in front of the first one which we have there, 2 minus x. And then we get this minus. Now we can see that this other one is positive, so we just get the way it is. Okay, minus x plus 2. Please always put brackets here. If you don't, it will affect your calculations. So that is for values of x which are greater than 2, like that. So we can go on now simplifying our equation. So if we want to simplify further, we go. That will be 2 minus x. Distribute this negative with that negative, it cancels, so it becomes positive x plus 2. And then we write what is the second one, 2 minus x. Distribute this negative, negative x minus 2. And then distribute this negative, that will be negative 2 plus x. And then distribute this negative, negative x minus 2. We know our regions, x is less than negative 2. Negative 2 is less than or equal to x, which is less than 2. Then x is greater than or equal to 2. And then we continue. Y is going to give us, so we can see here that this and this is going to cancel. So what we have is 4. Okay. And then this negative 2 and this will cancel. What we are going to remain with is a negative 2x. What else? So this one and this one is going to give us a negative 4. This is positive, this is negative, it is going to cancel. Okay. And then this is for x is less than negative 2. Negative 2 is less than or equal to x, which is less than 2. Then this is for x is greater than or equal to positive 2. So now we can go on now sketching these which we have. So I can rewrite them that side. 4 for x is less than negative 2. Negative 2x for negative 2 is less than or equal to x, which is less than 2. And then negative 4 for x is greater than or equal to positive 2. So what we are saying is, as long as our x is smaller than negative 2, the graph is going to give us 4. So our negative 2 is here. As long as we are smaller than negative 4, the value will be 4. So we are starting from 4. As long as it is smaller, it will go like that. We can also go to this one, which is, oh sorry, I've written another one. This is as long as, okay, I've written for this one, as long as our x is less than our, I think I even swapped these. I even swapped them at the end. Let me just describe that again. So this is positive 4, and we are talking of numbers which are, okay, this is less. So positive 4, it is fine actually. I wanted to confuse myself. Okay. This is less than. I forgot that is the less than symbol. So that is less than. As long as it is less than negative 2, our value will be positive 4. And this is positive 4, which is here. Now, as long as our x is positive, as long as it is greater than positive 2, let's have a positive 2 here, then our value will be negative 4. So as long as it is bigger than 2, the function will be 4, negative 4, like that. Of course, this is a negative. And then now between negative 2 and positive 2, the function we're going to use is negative 2x. So that will be y is equal to negative 2x. we can simply find some values, just simple values, x and y. Between -2 and 2, we can use 0 is the simplest we can use. So if our x is 0, what would be our y? So it is giving us when x is 0, our y will also be 0. If our x is -2, let's say if our x not -2, because we're talking of between -2 and +2. What number is there? Let's use a 1. If our x is 1, what will be our y? Our y, let's put a 1 here, it will be -2. So we're talking of 0, 0, which is here, and 1, -2. If this is our 1, -2 there, so it will be here. Now remember, the first one is for x is less than -2, so it was supposed to end here at -2, not this region where I reached. So now we just join these 2 points which we have. We've got this point and also this point. Let's join them. We see they'll pass like that, and then they'll reach up to 2. So this graph will touch like that. So that will be the graph for this function which we have. The absolute value of 2 minus x plus 2. It will be that one. So actually I wanted to skip out this one, but I just realized I saw a lot of questions from the past papers. So I decided to bring it on. Is that okay? Are there questions? Okay, if it is fine, then I'm going to, you can just copy these questions, you try them out, and then you can give the answers. Sketch So the first one, f of x being equal to 2x plus 3 minus 3x minus 3. Okay, you can sketch that one. You can also have Alright, so these are the questions you should try out, and then you should send the answers to my inbox by the end of tomorrow. You can send the answers to my inbox. So if you have copied the questions, I've ended here. You can just leave the meeting. Thank you so much for having attended. Have a blessed day or a blessed night for you who are